Keep that down to the gate.
I'm ready for her.
That's wide enough that a train can use it. You'll see that.
Podium. Excuse me. Thank you. All right, can everyone hear me properly?
Yeah.
Fantastic. So for those of you who did not ride down with me, welcome again to Hoover Dam. My name is Chase, and I will be your guide for the first two stops here. If you have a red wristband, if you have a blue wristband, you are stuck with me for the entire tour. Howdy. So just to orient you as to where we are after going down 54 stories in the Black Canyon, elevator shaft is right here. That cave we just walked down is this yellow line the contractors added. We are standing right here inside of this diversion tunnel. Now, we're going to have a task that is to build the Hoover Dam. So congratulations, you are all engineers and we are in this together. Now, first order of business, we've got to clear the construction area so our workers can work without scuba gear because that's expensive. We need to build 4 diversion tunnels. We have 2 on the Nevada side, 2 on the Arizona side. These are 50 feet in diameter and about 4,000 feet long each. Took the workers here 2 years to blast these out of the canyon walls. Once that's finished, you've got to encourage the Colorado River, which flows right here, into the tunnels that we've just created. To do that, the workers made 2 temporary dams known as coffer dams. They were built using the rock blasted off the side of the canyon walls and from blasting out of the diversion tunnels, along with some locally sourced sand and gravel from the Boulder City area. They have an upper coffer dam right here and a lower coffer dam right here to prevent the water from backfilling the construction site. Once that's finished, Colorado River flows into these diversion tunnels, goes around. Central part of the construction is now drained and cleared. Now workers have to dig out 135 feet of material from the riverbed to get down to bedrock, which is a nice solid foundation. Once bedrock is achieved, we have the concrete being drawn in here. And this concrete is being lowered in these massive buckets carrying 8 cubic yards of concrete each, which for reference, a concrete truck carries about 10 cubic yards of concrete. So just shy of a concrete's worth of concrete is going down into this canyon here. And that's arriving every 78 seconds, 24 hours a day, 7 days a week for 2 years. Which for reference, our elevator ride was only 70 seconds. So just 8 seconds more than the elevator ride to get down here, we had 8 cubic yards of concrete coming down into this canyon, pouring the concrete. As the concrete's being poured and the dam is rising up, we're shutting off these diversion tunnels, but leaving the outer Nevada tunnel open to allow river water to go around the dam and go downriver so we're not cutting Mexico off from the Colorado. It's not the polite thing to do. Final year of construction sees our 4 intake towers being built. We have 2 here on the Nevada side, 2 on the Arizona side. The water falls into these intake towers, goes down into the diversion tunnels. It goes into 30-foot diameter penstocks, like the one we're standing on right now. If you look out the windows to either side, you can see that really long pipe. That's the 30-foot diameter penstock. The tunnel that you see that it is in is the 50-foot diameter diversion tunnel. We don't really have a whole lot of water going through the penstock right now, but whenever we really get the water going, we can have up to 96,000 gallons of water per second flowing through these 30-foot diameter penstocks, which is enough to fill an Olympic-sized swimming pool in just 7 seconds. And actually, when you're in here, you can feel the ground shaking. You can definitely tell whenever they turn another generator on because the whole room shakes, which isn't very fun if you have claustrophobia, I've observed. But water goes from these 30-foot diameter penstocks into smaller 13-foot diameter penstocks to increase the water pressure. Then it flows into our powerhouse, spins the turbines and our generators, generates electricity, then goes out downstream. The lower cofferdam was removed to allow the water to just flow right back into its original place. The last thing I will bring your attention to complete our little project of the Hoover Dam are our two spillways. We have one on the Nevada side, one on the Arizona side, and these spillways are absolutely massive. In fact, you could fit the USS Arizona, which now rests in Pearl Harbor, in the Arizona spillway. These are 27 feet lower than the top of the dam, and there to prevent any floodwaters from overtopping the dam. We don't want to wash any cars away, it's bad for PR. Now, these were used twice. First in 1941 to test if they would work. We deliberately overfilled Lake Mead. Water went into these spillways. These worked as intended. Water went downriver. Crisis averted. But the second time they were used was for real in 1983 after heavy snowmelt in the Rocky Mountains caused the Colorado River to rise. Water flowed into these spillways for 63 consecutive days. To my left, you can see a picture here. We have the water going into the spillway. And just beyond it, you can see barely the top of Hoover Dam. Water reached within 7 feet of the top of Hoover Dam. That being said, I will lead you guys back out to the elevator, so if you please just wait for me and I'll take you back. If you have any questions, please feel free to let me know. Excuse me.